Okay, so today we want to simplify algebraic expressions involving radicals, right? And we've done numbers, right? How do we do root 72? Well, root 72 looks like this. So the root of 72 is 36 times 2. So we take the largest perfect square, the largest number that has a square root. We write 72 as a product of 36 times 2. And the root of a product is the product of the individual roots, right? So we split this up. And then root 36, so we pick something that has a square root. So it's 6 times root 2, and we just write that as 6 root 2. Right? And oftentimes we'll just go straight from root 72 and just say that's 6 root 2, right? And everybody's fine with that. But how do we simplify something like the square root of x to the 10th? So in this case, the variable is expressed as a power, right? We have a variable x, and it's got a power. So what we need to do is we're going to go to exponential form. And in Math 10C, we learned that we can express the square root in radical form, right? So you can write the square root of 9, or 9 to the power of 1/2. So we use an exponent of 1/2. And we call 9 to the power of 1, we call that a power, right? It's got a base of 9 and an exponent of base and an exponent of 1/2. And we know the exponent laws, which say when you have a power to a power, you multiply the exponent. So if we had 7 to the power of 8, and we wanted to take the square root of that, we'd raise it to the power of 1/2. Exponent laws say you multiply power, so it's 7 to the 8 times 1/2, or 7 to the power of 4. So we look at square root of x to the 10th, and we change it to x to the 10th to the power of 1/2. Then we can use the exponent law, so that's x to the power of 10 times 1/2, or x to the 5th. So to simplify square root of x to the 10th, we cut the power in half and remove the radical sign, right? So the easy way to do that is just have the power. You have the power. Only in this case it's held. You held the power. So you just cut the power in half, right? So that's nice if it's even, right? X to the 10th, half of 10 is 5. Easy peasy. What if we have an odd exponent? So how would we simplify x to the power of 11? Well, what we're going to do is, just like we did up here, right, we're going to split it into something that has a square root, or for us, something that has an even exponent, and then what's left. So we take x to the 11th, we write it as x to the power of 10. So all you do is just go 1 lower than 11, right? We're just going to go to the lowest even number below that. So just subtract 1. So we write it as the square root of x to the 10th times x, which is the square root of x to the 10th times the square root of x. Okay, we know how to do this. You just cut the power in half, so that's x to the 5th. Remove the radical sign. X to the 5th times root x. Or we just write it as x to the 5th root x, right? So we pull the x to the 10th, the even power, we pull that up front, pull it out of the radical sign, cut it in half, and there we go. So even, if it's an even exponent, just take half, and if it's on, and I apologize for the little screen jump there because we moved the screen. So what are we going to do with w to the 15th? So we want to write it as the highest even number, which will be 14 times w. So that's the square root of w to the 14th times root w, and the square root of w to the 14th is w to the 7th. Okay, so all you're going to do, if it's an even power, if it's like x to the 12th, then that just becomes x to the 6th. If it's an odd power, then you split it into, basically you just subtract 1 from it, cut that number in half, write it out front, in front of the radical, and then put a root of whatever, right? Because the rest will be a power of 1. So let's try this. Let's say we got 50, the root of 50, x to the 7th. So we're going to say, okay, it's 25. So we're looking for something that has a square root. That's 25. X to the 6th times 2. So 25 times 2 gives me 50 times 2x. So we then have the thing that has the square root, 25x to the 6th has a square root, root 2x. Square root of 25 is 5. The square root of x to the 6th is x to the third. So our answer is the root of 50x to the 7th becomes 5x cubed root 2x, right? And so if we had had root 50, you could go straight to 5 root 2. Then the fact that we have this x to the 7th, right? You're just going to say, all right, that's odd. I'm going to go down 1. I'll have x to the 6th. So if we had root 50x to the 7th, you're going to go, I got 5. X to the 6th will be x cubed. Right, that's my 25, root 25 became that, and then a root, and then 2x. And if there's ever an x, if it's an odd, there'll always just be an x to the power of 1, right? If we were doing cube roots, we don't do cube roots, but if we did cube roots, then we'd be looking for a multiple of 3. But we don't do that, so. All right, simplify following. What is the square root of x to the 8th? It's an easy one, right? This is straight up. X to the 4th. What is the square root of w to the 7th? So you don't have to show any work. I wouldn't. Let's see. So does everybody get w cubed? Root w? Yes? No? Oui. Oui, oui. Mais oui. Y to the 12. Square root of y to the 12. Y to the 6. 64. Square root of 64. What's the square root of 64? 8. It's an easy one. What do we do with the square root of x to the 9th? Subtract 1, it becomes x to the 8th. Cut the 8 in half, move it out of the radical sign, and we get 8 x to the 4th times what? Root x. So anytime it's odd, there's always going to be a root x, right? It'll just be root x to the power of 1. Just the root of x. Okay, 20. W to the 10th. So I'll let you try that one. I'm going to do the full meal deal. Like I'll show you the full blown. What will this look like? So what I want is things that have a square root, right? So the largest square that goes into 20 is 4, right? So remember our squares, we got 4, we got 9, we got 16, we got 25, etc. So 4, since the power on the w is even, it has a square root. Then we would split it up and say, well, it's the square root of 4w to the 10th. That has a square root times the root of 5. The square root of 4 is 2. Square root of w to the 10th is w to the 5th. So the square root of 20 w to the 10th is 2 w to the 5th root 5. Okay, same thing. Now you can do this in your head, right? You don't have to write it down. But what I can do is say, okay, what are my squares? Well, 4 w into 27. 9 goes into 27 3 times. So I have 9 as a perfect square. Since it's y to the 12th, I know that's even. Then I'm going to put that y to the 12th here. So the 9y to the 12th has a square root. And to split that out, the square root of that is 3y to the 6th root 3. So, yesterday or before, you would have taken root 27 and just written it as 3 root 3, right? And then all we've done is we've added in and said, okay, there's a variable there now. So let me extend the page. Okay, 3x root 75x to the 5th. So just put the 3x down. That's just going to be sitting in front, right? And we're going to simplify the root of 75x to the 5th. Okay. Now, you could just do this all in your head. I would probably write at least one line. Like do the 3x and then do the root 75 if you can. Okay. Or, full details. So the biggest square that goes into 75 is 25, right? Then the even power. And then the things that don't have square roots, right? So we've got 25 times 3 is going to give us 75. Okay. Then we split that out and we write the first radical because it has a square root, and we write the second radical, which doesn't have the square root. The square root of 25x to the 4th is 5x squared. Right, and we just combine these two, so we get 15 x cubed square root 3x. So that's what we're looking for. When you're doing the homework, make sure you're checking every answer. Do a question, check the answer, do a question, check the answer. If you're getting things wrong, try and figure out what, right? So remember, we do what's called fix-it focused practice, right? So as we do our practice, we're checking our answers, and if we get it wrong, then we're trying to fix it at that time, right? Don't go through 10 questions, find out that you don't know how to do them, in which case you've taught yourself to do the wrong thing very well, and we don't want that, right? Okay, so I got a W there. I'm going to look at that. I'm going to pull out, I'm going to make the 13 into a 12, cut that in half, pull a W to the 6th. So I'm going to have a W. The square root of 4 is 2, so I'm going to have a 2W to the 6th root W. You get 2W to the 7th root W. Okay, just to show you don't need to necessarily do the full thing. You can if you like, right? You always have the option of just, hey, you know what, I just want to show all the work. I just want to show every step. I feel more comfortable doing it that way. So you have to work within your comfort zone, right? What am I comfortable doing? Am I comfortable taking 4W to the 13th, square root of that, and writing that as 2W to the 6th, root W? If so, that's fine. You just do that. Okay, so try F. See what you get. I'm going to pause this. So there's the first couple of steps, right? We write 8 as 4 times 2 because 4 has a perfect square, right? We're looking for a perfect square. We got an even power of y. It stays there because that has a square root, right? Square root of y to the 6th. So what is the square root of 4y to the 6th? 2y to the 3, right? So we've got our negative 2y squared. That's just pulling its way down. Give me half a second. 2y cubed. Right? And then we've got a root 2. Okay. Any observation here? Okay, and then we're just going to combine. So negative 2 times 2 is negative 4. Y squared times y cubed. When you multiply powers with the same base, you add the exponents. That becomes y to the 5th. And we got a root 2 in there. Okay, any questions? Comment? Concern? Okay, everybody good with that? All right. Restrictions on the variable. So you can't take the square root of what kind of number? Negative. A negative number. Right? So we cannot do the square root of a negative number. So when a radical has a variable, So if there's an x underneath there, we must state the values for the variable that are valid, right? So if I have square root x, it's valid only if the RaDiCal, that's the RaDiCal, is what or what? What's the smallest value we could put in for x? 0, right? Because we can do the square root of 0. What's the square root of 0? 0. That's cool. So it's got to be 0 or it's got to be positive. Well, we can just say positive. So 0 is like the Switzerland of numbers, right? It's neutral. It's neither positive nor negative. So in this day and age, is Switzerland still neutral? No, it's not. Yeah, it's not. So, okay, 0 is no longer the Switzerland of numbers. It's not neutral anymore. So, but 0 is neutral. It's not positive and it's not negative. So if we want to say 0 or positive, the fancy way, I will never ask you to say this, the fancy way of saying this would be to say non-negative. That is a fancy word. That is fancy, right? It's not negative. So if it's not negative, what is it? It's 0 or positive. Right? I'm not going to ask you to say it. We just stick with this. What are the details? It's got to be 0 or positive, right? What are we going to really say? The restriction on x is, we're going to say x is greater than or equal to 0. So that's our restriction. X must be greater than or equal to 0. Okay, that's root x, right? What if we have the root of x minus 5? Now that's only valid if the RaDiCal, in this case, that's the RaDiCal. So what can x minus 5 be? Or what must it be?
5 or greater.
Well, so the RaDiCal, that expression must be 0 or positive, right? That expression. So 0 or positive. Same deal. Whatever's underneath the radical sign. Which means that x minus 5 must be 0 or positive, right? So that's the RaDiCal. And we say the restriction on x is, so what value of x is going to make x minus 5 greater than or equal to 0? Yeah, if x is greater than or equal to 5. Right? So if x is 5, x minus 5 will be 0. We go, that's okay, you can do the square root of 0. If x is greater than 5, x minus 5 is going to be positive. We say, well, that's okay. So what we would say is, I need x minus 5 to be greater than or equal to 0. I need whatever's underneath there to be greater than or equal to 0. And if we solve this, we would say then x must be greater than or equal to 5. Right? So we take the RaDiCal, the expression under the radical sign, and say that must have a value greater than or equal to 0, and then we just solve that. Root of x to the 4th is only valid if the RaDiCal is, wait for it, 0 or positive, right? Yeah. Sometimes it's pretty boring, right? But boring is good, right? Like you were a math test, you turn the page and it's an exciting question. That's not a good thing. It's, oh, look at that. I've never seen anything like that before. Right? It should be, oh, look at that. I did 10 of them yesterday while I was studying. No problem. I'm going to do that. So, if w to the 4th is going to be 0 or positive, then w could be positive, right? But if you're raising it to the 4th power, what else could it be? Yeah. So if you raise a negative to an even power, it becomes positive. Okay, so the RaDiCal, that expression, w to the 4th, doesn't matter. It could be positive, it could be negative. And we say there are what kind of restrictions? So there's no restriction, right? If w is negative, let's say negative 3, we're going to raise it to the 4th power, which would be negative 3 times negative 3. times negative 3. So if w were negative 3, and then usually what I'd like to do is just put parentheses around there, just emphasizes that it's a quantity, negative. Negative times a negative is positive 9, negative 27, positive 81, right? That will be positive. So if you're raising a negative to an even power, the result is positive. If w were 0, 0 to the power of 4 is 0, that's fine, right? Because the RaDiCal would be 0 or positive. Square root of p cubed is only valid if the RaDiCal is 0 or positive. Sometimes math is easy. Like the fourth time through. But if I'm cubing p, then p must be, well, it could be 0, right? Or what? Positive, right? Because if we cube a negative, so if I stopped here, hard to say that one, you can't see, but if we didn't do the last 3 here, right, that would be negative 27, right, if that was being cubed. So if we're cubing, if we're raising to an odd power, then the RaDiCal could be 0, right, or positive. And so the restriction on p is, p must be greater than or equal to 0, right? So anytime we have an expression with a radical, and there's a variable underneath the radical sign, we have to be careful about restrictions, right? So here, state the restrictions on the variable for each of the following. Now notice, it doesn't ask us to actually do this, right? It doesn't say simplify, it just says state the restriction. So if x is being raised to the power of 4, what's the restriction on x? None. So what do we say? We say, well, x is an element of the real. And the reason is the simplified form of this is just 8x squared, right? Remember, they didn't ask us for that, but that has a square root, right? So there'd be nothing under the radical sign to worry about when it's simplified. Negative w, what do we want negative w to be? Well, we're going to say, well, I want negative w to be greater than or equal to 0, right? So odd power, if it's an odd power, it's power of 1. Odd power must be greater than or equal to 0. Now, what we do here is we take the negative of both sides, and then we have to flip the inequality. So that says, as long as w is, basically what that says, as long as w is 0 or negative, then we're okay. Right? So if w is negative, we're doing the negative of a negative, and what's the negative of a negative? Positive. Positive. Are you sure? I'm positive. See, the phrase I'm positive used to have a different meaning before March of 2020. The meaning has changed. What do we want y plus 3 to be? Y must be greater than negative 3? Yeah, oh, you're jumping. You're one step ahead. So we want y plus, we want the RaDiCal to be greater than or equal to 0. Right, which means that y, we're just going to subtract 3. Right, so the inequality sign stays the same if we are just adding or subtracting the same number from both sides. Inequality stays the same if you are multiplying or dividing both sides by a positive value. If we multiply or divide by a negative value, then the inequality sign flips, right? So here, I either multiply both sides by negative 1, or I divide both sides by negative 1. Right? It's not going to change 0, but it will flip the inequality. The square root of x cubed. What is the restriction on x? Okay, except what can't x be? What can't we divide by? Oh. Right? So normally, right, you're looking at the square root of x cubed, you're going to say that x cubed, right, has to be greater than or equal to 0. Then we say, but hang on, you're dividing, right? So x must be strictly greater than 0, right? Because we are dividing by x, so we cannot divided by 0, so x can't be 0. So the cubed here, if that was x to the 4th under there, we'd say x can be anything but 0, right? So we'd say x cannot equal 0 would be the only restriction if that was an even power, right? Because if it's negative, we don't care. But we do care to say, oh, it can't be 0 because you're dividing by x. Right? So just something else to watch out for. One last thing. State the restrictions on the variable and then simplify. Okay, so this is a big skill in Math 30-2, right? Like the next course up, there is a whole pile of stuff on restrictions, and they're called restrictions or non-permissible values. We're just going to call them restrictions, and we're just going to say what x can't be, or we're going to say what x must be. So here we're going to say what's the restriction that x has to be, so it's just an x. So x must be greater than or equal to 0, right? So we'll start with the restriction. We look under the radical sign. We say, what's there? An odd power. Okay, what do we do with odd powers? Well, that means that x has to be greater than or equal to 0. So that's our restriction. Now we got to simplify each of these. The first one is done for you. So root of 12. Now, you can show as much or as little as you want, right? So I'm showing more rather than less. What that be? Oh, okay. So if you have an eraser and it doesn't work, I have another eraser and that. Now, okay, wait. Fun time.
Have you tried clicking the eraser on the black?
That one? Yeah. Oh, wait. Well, that got rid of the red. I can get rid of the red. Yeah, I know. I don't know. Wacky. Go back to a pen. All right, I don't know what I'm going to get here. Red, apparently.
If you erase the red and then press exit drawing on the corner of the board.
Oh.
You should erase the red first. Or not.
It went away. All right, let's see.
Yay!
Yay, we learned something. Leave a comment in the comments on YouTube. If you too want to learn how to do whatever it is I didn't know that I was doing. So on this, I'm going to do the full detail, right? So you could do, I would say, like you could write root 12x as 2 root 3x. Then I would go minus 2 times, and if you want to simplify the root 75x, go ahead. Right? I'm just going to show you more detail. So for those of you that like to see the detail, right? And again, you can show, I'll show you what you could do. Right? So here, so this is 2 root 3x minus, I'm going to go like one more. So 2 root 3x minus 10 root 3x minus root 3x. So how many root 3x's do we end up with?
3.
So I got 2 minus 10 is negative 8. Minus 1 is? Negative 9 root 3x's. So I would say, what work should you show? You could go from here straight to this line here. Okay, well you're just going to say, hey, root 12x is 2 root 3x. Root 75x is 5 root 3x. right? So I'd want to see that. I'd want to see like 3 lines, 4 lines, right? Like show me at least this line. So 1, 2, and then the final answer, 3. Okay, and I'm showing you those extra 2 lines just for those of you that, you know what, I just like to see the whole thing. So to separate that out, we're going to give this a try. So I'm just going to say the square root of 16 is 4. And if I got y to the 10th, I'd just take half the power. Right? So I wouldn't mess around with that one, writing it as like the root of the 6. Like it already has a square root, which is 4y to the 5th. Plus 2 what? Y to the 6th. Right? We just have the power. You should have seen the lesson before. It was like mess. So I get negative 20y to the 6th plus 12y to the 6th, which is? Right, so we just deal with the numbers, coefficients. So negative 20 plus 12 is negative 8, and negative 8, what? Negative 8y to the 6th. 6. Okay, we're going to multiply.
How'd you get 12y to the 6th?
I don't know.
2y to the 6th and negative 8.
Yeah, how did the 2 become a 12? That's a good question. Negative 8. I don't know what you're talking about. It always said that. It's right there on YouTube. Yeah, play it back. I'm not going to go in and edit this, right? If you mess up, own it. How it became a 12. It's weird. I was probably looking at the 2 and the 6. So sometimes on your test paper, there's like a little question mark there going, how'd you get that? You go, I don't know. How'd you get that? I don't know. Okay, so we can, let's do a little bit detail. So we got negative 4 times 5 times the root of w to the 5th times the root of w to the 9th. Negative 20. Ooh, look at this, we got lag. Look at w to the 5 plus 9. Negative 20 root w to the 14th is equal to negative 20 w. So, and back on there. Okay, and like, you know what? I'm okay if you go like here and then here, right? Go negative 4 times 5 is negative 20. I have the root of, and I'm going to add, right? So remember, the product of radicals, so root w to the 5 times root w to the 9, is the same as the radical of the product, the root of w to the 5 times w. That's not an exciting question. What are you trying to say? 2 root p times 3 root p cubed. Okay, less detail. 2 root p to the 4th. Right? I'm just going to get straight there. The root of p times the root of p cubed is the root of p cubed times p, which is the root of p to the 4th. Minus 12 root p to the 8th. Looking for the eraser. Usually I'm better in the afternoon. You should see me in the morning. Way more mistakes. Okay, so what's this going to be? 6p squared minus 12, what? p4. Ooh, ruh-roh. Division and rationalizing denominators. I'm just going to sort of clean up the bottom circle part of that. Whoop. Not clean. Okay, hang on. We'll clean that up. I need to save this. What was that? Negative 9 root 3. Okay. I got to save these notes and put the notes up in Schoology as well. 15. Root of w to the 7th over the root of w cubed. Or 15. So what's 15 divided by negative 5? What's the root of w to the 7th divided by w cubed? That's going to be w to the 4. Okay. So I can put them together here. We'll do a little more detail. Bring this up a bit. Okay, so 15 divided by that's negative 3. We can put these together under the radical sign. So the quotient of individual roots, right? I got root w to the 7th divided by root w cubed individual roots, is the root of the quotient, so a single root, in w to the 7th over w cubed. What do we do when we divide powers with the same base? We subtract. What's the square root of w to the 4th? W squared. Right? Everybody good with that? So that there's a quotient there, right? We're doing division, but it just simplifies. Unlike the next one. So the next one, we have to rationalize the denominator. Right? So what we're going to do is we multiply by the radical. So in this case, actually, it's just root x. But if you multiply the denominator by root x, you have to multiply the numerator by root x as well, because this expression, root x over root x, what's that equal to? That's just 1. If I multiply by 1, do I change the value? No, I'm just changing the form. Okay, now we're going to have to do distributive law. So we have 20 root x times root x, which is the square root of 20 x squared. That's real slow. I know, I like the lag. Plus 8 root x to the 4. Over how much? Okay. Over 2x, right? Root x times root x. Now, if you like, you can write that as root x squared, right? And then we'll deal with it on the next line. So, root 20, right, is 2 root 5. So this is going to be 2x root 5. This next part is going to be plus 8x squared divided by 2x. I'm going to say, oh, hang on, that simplifies, right? Because 2x, 2x, and 2x will go into all of these. So if I like, I can factor a 2x out of the numerator, right, which will give me root 5 plus 4x. Okay, and just check that, right? 2x root 5 plus 8x squared divided by 2x. Cross those guys off, 1 and 1. And that's equal to root 5 plus 4x. And now, I think it asked us to state the restrictions, and I only did that for the first one, so we better go through all the rest of them and state the restrictions. Okay, so y is an even power. What's the restriction on the y's in B? That's an even power, right? So y belongs to the root. There's no restriction, right? It's an even power. It's negative. We're not dividing in any case, right? So we're going to have to watch out when we're dividing. Here, these are odd powers. So what are we going to say? Yeah. Waiting for the circle to complete. W must be greater than or equal to 0 here because we are doing roots of an odd power. P must also be greater than or equal to 0. Let's throw that up here. So same deal, right? We've got odd powers. How about this? So normally we'd say greater than or equal to 0, but there's a W in the denominator. So W has to be greater than 0. Right. And then the same thing here, because there's an X in the denominator. Restriction means X must be greater than 0. Any questions? Nothing happened. Okay, so why is that down? That's interesting. Why is that? All right, got to multiply. So we're going to FOIL this, right? First, outer, inner, last. So first, so you can go 3 and then root x times root x is x, or you can go 3 root x squared minus 3 root x, so that's the outer, plus 5 root x minus 5. The square root of x squared is x, so that's 3x plus 2 root x minus 5. Anytime I see a binomial that's squared, then I just like to write it out as, okay, what is this? It's 2 root w minus 6 times 2 root w minus 6. Right? And then just FOIL it out. Right? That's the easiest way. So 2, now I'm going to do this. I'm going to go, so 2 times 2 is 4, root w times w is w, right? When we square a square root, minus 12 root w, minus another 12 root w, plus, so minus 6 times minus 6 is plus 36. So 4w minus 24 root w plus 36. Right, and one last one here. FOIL 8 root w. So minus, because of the minus sign, minus 2 root w times root w is w. Minus 24 plus 6 root w. Okay, so when we're squaring a square root, then we can just write that as, you just remove the radical sign, right? So root w times root w is just w. So we get 8 plus 16 is 14. That's not a 4. It's 14 root w minus 2w minus 24. We're going to say order doesn't really matter there. Maybe, I don't like leading with negatives though, so I mean that's fine. As long as you've got all three terms, they've got the correct sign. That's good. Okay. Last one? Is this the last one? All right.
Looks like it.
Yeah. Well, there are those of us who thought we were done earlier. We're doing a rectangle. I like to draw a picture. A rectangle is a length of 4 square root x cubed and a width of 5 root x. What's the formula for area of a rectangle? Length times width. 4 square root x cubed times 5 square root x is 20 square root x to the power of 4, and the square root of x to the 4th is so we get 20x squared, right? That's our expression. 20x squared.